Excellent connection. Yeah, I think I am live. Cool, I can see here on my phone. Welcome everyone to this stream. I see that we have some viewers, so please send me a message here on the chat so I can be sure that you're receiving my video correctly. Let's hope that the internet's gonna be all right through this stream. So today we're gonna be working on the OSMU power amplifier PCB design. So as you can see here, I already have the schematic ready on this time. I already did some preparation during this morning. So I already have all the components here. So we're gonna be making the layout for those components, routing this PCB, and hopefully having it ready until the end of this evening. I hope so. I think this is gonna take many hours, so let's hope for the best. So I wanna go through with you guys on the schematic first, explain a little bit what I'm doing here. So this, first of all, this amplifier is based on one of the amplifiers designed by Wilfred Hill, and one of the authors of The Art of Electronics. So if you're more interested, like in how the circuit operates and its characteristics, you can check his book. It's a good source and explanation of it. But basically, this is a very high-speed amplifier. This amplifier originally was designed to work up to 10 megahertz, 5 amps. So it's a really powerful amplifier. We had to make some changes on the amplifier first because all the parts were through hole, and we are moving to an SMD, basically assembly process. And yeah, we really don't have a way to keep through hole. Because of space constraints and mechanical constraints, and also, like, for example, the output transistors originally used by Hughes, they are not available anymore. They were transistor used for like CRT screens, and yeah, so they ran out of phase. So for this reason, yeah, I'm gonna be layouting this amplifier with those new parts. As you can see here, we have some new transistors, and those are from Xperia. And they have like a little bit more output capacitance than the original ones, so we don't expect them to perform as well. But it's okay because we don't want more than 1 megahertz of bandwidth, and like, so it's one order of magnitude less than it was originally designed, and we are not even doubling the capacitance in the transistors, so it should be pretty okay. And actually, the source measure unit is going to operate up to 100 kilohertz. So it's basically 2 orders of magnitude less than what the circuit is capable of. So we have a lot of slack on this design. So yeah, so here, as you can see, what I have in the middle of the schematic here is the output transistors. We have a lot of parallel transistors. The reason for that is that, especially when we are sinking current, well, the SMU is going to work in a 4-quadrant space. We have thermal limits what each one of the transistors can dissipate of power. So we have a very heavy thermal constraint on this design, much more than the electrical constraint. So it's a big limiting factor. So I'm gonna go through when we go to the PCB. I'm gonna show you guys, but just for a quick reference, all those transistors that they have like the sign here, it means that they must be in the same heat sink, and there is some thermal coupling that must be observed here. So we have the main 10 transistors here. They are our main source of heat. And then we have the auxiliary drivers and cascode transistors that are basically, they need to track thermally the transistors. Hey, Kat. Yeah, so this is the main part of the design. Then we have some DC-DC converter. They are isolated converters here, and the reason is because we need to generate in a few rails a voltage over our main rail. So here you see that we have a reference for 48 volts, and we need to have 5 volts more than those rails. So those isolated DC converters, one here and one on the positive rail, they are generating those floating voltage over our main rail. What more? Then we have TL421, that is basically a reference for our current source here in both of the sites as well. We have 2 of them. And here we have the compensation network. So our feedback. So we have a very like high impedance region on this part, and we have our input here that is composed by this LT1360 that is converting our voltage input to a current source. So yeah, it's very straightforward, high-speed amplifier. Yeah, and here we have 2 header pins connectors. The reason that I'm using those header pins is basically we want to stack amplifiers one over the other one. And the deal there is that we are sharing the pins, so voltage rails and so we need a connector that allows us to stack the amplifiers one over the other one, and of course we're going to have the heat sink between them, and so for that reason, we're going with header pins, because they are kind of Arduino style that you can stack shields, and we have many lengths of pins that you can acquire in the market. So was the easiest solution, and I'm just like duplicating pins here. Yeah, and our idea is to have maximum 3 of those amplifiers stacked, and for this reason, I am dividing here the output in 3, as you can see here. I have a small change to do here in the schematic, but we're gonna leave this for later. I don't need to do this right now. That is, we need to have kind of like a solder jump to select each one of those outputs we have here, because since we didn't define yet how we're gonna do like the current measurement, and so I'm basically splitting the outputs in different pins so we can treat and shunt those outputs to measure current individually. And so we keep the boards like they're gonna be like similar, but at the same time you are gonna have those solder jumps to define out where you wanted to send the output signal. And I also add here some pins for the feedback because here we are keeping this feedback network as was designed originally. So I decided to also put on the header pins like access to those lines. So if you remove this resistors here, for example, we could cut this feedback line and we could put additional compensation, like for example, a crossover in the analog front end, and then we can change the feedback loop behavior for each one of those amplifiers. So yeah, it's very straightforward. So let's go. So let's go now to the PCB. If you have any questions, let me know in the chat. I'm following your messages. And yeah, so here we have our main PCB. I already prepared the board layout so we could be more straightforward in this board routing. Otherwise, we would stay like 10 hours here. So just to give you guys some context, this is the board layout that we are working on. And just to give you a quick reference, this board is basically going to be attached under a server processor heatsink. I'm going to show you guys here on the website one of the heatsinks that we are targeting. Let me change on. Yeah, on OBS here. Okay, so this is the style of heatsink that we're gonna be using. Is for LGA Intel server processors. And yeah, so basically this heatsink itself, it has like a dimension of 90 by 90 millimeters. And the distance between the mounting holes is 80 by 80. So I already put I create a footprint for the heatsink holes here in Altium. So we basically have these measurements, and because we have the header pins going through all the modules, I had to create this lip here, and yeah, and place the connectors here so they are not gonna interfere with the heatsink. So we're gonna create like a wind channel with the fence through the heatsink, going from left to right or right to left, and so we can achieve our cooling. So on this orientation here, the heatsink is gonna be on the bottom of the board, and we're gonna populate all the components in the top side. And since we are using SMD components, we basically can attach the heatsink with a thermal pad, a thin thermal pad under the whole board, so we basically can dissipate the heat. This heatsink here that I showed you guys, it's basically, they don't have a picture here, but I already saw the bottom of this heatsink. But if you look like here, you can see that more or less in the middle of the region there is a heat chamber. A vapor chamber, I think is how they call it. And so it's optimized to extract most of the heat from the middle. So as you can see here on the Altium, those grid lines, those yellow grid lines that I put here, those are the official specification from Intel about the surface the processor needs contact with the heatsink. So the heatsink is optimized to sink the heat from this middle region. For this reason, all of our output transistors, they're going to be placed here right in the middle. and all the transistors that we need to track mostly accurate as possible the temperature we're gonna put all around them, and all the components that don't need like hard temperature tracking, they're gonna be spread around. The base of this heatsink, it's copper, so we're gonna have a good spreading, but I really wanna optimize the heat sinking from the middle of the PCB. We're gonna have thermal vias connecting the top with the bottom. We're going through with a 4-layer design on this board. And I was considering to use more layers, but I came up with a strategy that 4 layers is gonna be enough. So basically, we're gonna have the top layer where all the components, of course, are gonna be there, and all like the low impedance, like high noise signals are gonna be routed here. Then in the middle top layer, we're gonna have any positive rails, power planes. And then in the middle bottom, we're gonna have a single ground plane. And in the bottom, we're gonna have additional like connecting like thermal planes. And we're gonna have also like low impedance signals, like for example the feedback. So this way we have an entire ground plane shielding against interference with the output, with the input. So I'm gonna optimize this way, and also because we have the heat sink, so we are creating like a sandwich, like shielding all the like sensitive signals. So I think this way we're gonna have the best protection from our input and feedback signals. Yeah, exactly. I'm not sure if we're gonna be able to fit all of them. I'm gonna do my best. In worst case scenario, we're gonna increase the PCB size. As you can see here, we have all the transistors. So let's start moving. I already like more or less organize it, like only the transistor, all the other components are not organized. And yeah, if we make it tight, we basically can fit basically almost all transistors in our like high heat dissipation area. So I'm very happy about it. I just need to select which are the output transistors first. I didn't make any separation, so we're gonna do it together right now. And yeah, and then we can just like start. So we're gonna start from the middle to the outside words, and my only restriction is basically here in the height of this board, because we want to keep a 3U maximum height. I'm not sure if it's gonna be ideal. Ideally, I personally would like to go with 4Us, because we could use bigger fans and have more red room for a few ideas that I have of the mechanical part. But like here in the horizontal dimension, we can increase. There's no issue. But yeah, but I want to keep it like the SMU as compact as possible. Yeah, so we can have a compact SMU. Yeah, Kat is telling me here in the chat that the resistors that are going to the emitters of our output transistors, they must be as close as possible to the transistors. So this is kind of a bummer, and yeah, there's no way around it, because we need to keep a low inductance on this part. So my idea is to have actually a plane there. So I'm gonna make basically an output plane on this region, and to tie the output. And then we needed to have those resistors around there. So I'm gonna see this when I actually start to position the components. So let's start first separating our output transistors. I'm gonna go back on the schematic, and let's start by the high side. So I have key 8, key 10, 11, 12, key 9. So 8, okay, so 8 to 12 are the high side output. So 10, 11, 12, key 8 and key 9. They already are more or less. So oops, I just moved something. Yeah, let me just lock this heatsink. And since like here in the bottom is gonna be our header pins for the output and like voltage rails, and here in the top is gonna be our input and feedback. So so basically the schematic that you see here from left to right, I'm gonna basically follow top to bottom. So the transistors in the end, they're gonna stay more like this. So yeah, so let's consider that our high side is this side. It is just helps me to organize my mind how to keep those transistors more or less like aligned with the schematic. Is just easier to think. So it is something that I always try. I actually, when I make my schematic, I always try to make the schematic more or less how I would like to organize my PCB, because this way I can already like start thinking about the layout constraints that I'm gonna have on the PCB. It's like, since usually I do both schematic and PCB, then I already do like this work ahead and start like thinking about it. Okay, so now let's see our low side transistors. So is key 13 to key 17. Key 13, oh, they are aligned as well. So let's put them like so, but I would like this to be here, this one to be here, you here. Okay. So now I'm gonna grab all the resistors. So I have here R28 to, okay, so 24, 25, 6, 7, 8. So 24 to 28. So let's locate those puppies, and they are big. They are very big because there's a lot of current going on here. And yeah, 24, 28. So where are them? Those are very, okay, 24, 25, 26, 28. So as you can see, they are actually bigger. Kat, are you sure that we need so big resistors? They look a little bit excessive to me, but yeah, I can double check it afterwards. Yeah, and it's kind of like a bummer. And I need to check. Kat, since you are there, check to me, because I think there's an error on this footprint. Because as you can see here, the pin 4 is not connected to anything. And it's kind of rare. I never saw like a transistor with like a pin unused, because usually they... oh, thank you, Waze. Yeah, I never use this on the port schematic. Thank you for the tip. So Kat, check to me if the pin 4 on those transistors for next period, they are actually not used, because usually you have 3 for the emitter and you have one for the base, and it's not what we have here right now. So I didn't have chance to check all the footprints was Cat that actually made the schematic that is with you guys in the chat, and I just made a few reviews. I changed a few components to SMD that he had a chance to change, and I checked a few components. So yeah, so I am just seeing right now that there is some issue with the transistor. I think that pin should be joined together, probably in the emitter. Anyway, let's grab the other. So yeah, so let's use the Y. No. I need to learn how to use this shortcut first. So now we have 13 to 17. No, sorry. 39, 40, 41. Okay, 39 to 43. Let's find those. Let's see if those. No. Usually they are like kind of in blocks. R39, where are you? As you can see, I didn't organize those components. Yeah, I am right. 39 to 43, yeah. Why can I find? Ah, here. But it's not seen. Oh, here, 43. They are kind of. Okay, so here is. Okay, so yeah, so there's a problem on the on the library. I'm gonna fix that. Yeah, I'm gonna need to fix that right now because I already like organize it. Let's see if I can find here the library. Properties. Okay, so it's in miscellaneous device. Okay, that's gonna delay us a little bit, guys, because it is on an integrated library. So I'm gonna need you to copy, and I'm gonna open any PCB, this one for example that I was working on. Wait, yeah, and I'm just gonna add here our NPN, I guess. Yeah, for now, just where is copy? Come on, Altium. I know you can copy from the schematic. I already did this. It's not copying the symbol. Just when I need to be fast on this kind of stuff, starts like to. Okay, so if I cannot do it, I'm just gonna grab this component name. This is like fast and dirty component creation because I can't lose a lot of time. Otherwise, you guys are gonna get bored. And Now I need to figure out the footprint name. It's not my fault, guys. It's Cat's fault. He can't properly organize his libraries. I just get crazy, you know. No, please, selected it. Fucking out. Alright, started to swear. Okay, so we add our footprint. So that's made, and now we are just gonna create our. So 1, 2, and 3 are the emitters. So emitters. One, if I remember, no, that's 1, 2, and 3 are the emitters. Then the 4, as I suspect, is the base. And our 5, the tab. Let me see. Judy, what is? Let me. Altium sometimes just don't wanna collaborate. Let me go there and see. Please just show me the tab. Let me try 5. If it doesn't work 5, then we find a way afterwards. So that's gonna be our. Oh no, this is collector before we. Oh yeah, I think you are right, but yeah, I was almost sure that we actually could do it, but yeah, no circle. So let's just try to change this right now, and I needed to find its name. Hey, now we have our ugly transistor that is like, oh my gosh, it's so much bigger. No, I'm gonna need you to do some workarounds here. You sent me on Discord. Okay. Yeah, but you sent me the PCB lib. I need a schematic lib or an integrated lib. PCB, I already have the footprint for it. So now it does not grab my component. And now this schematic is full of like go away, please. go away, please. Yeah, I know. It's ugly, but yeah, do you want me to waste like 30 minutes making a nice footprint right now? I don't think so, right? Let me see if it worked. Like, first I need to go there, annotation. Nope. Okay, so now don't worry, guys. I'm gonna fix the. Where's my transistor now? Yeah, I think it's this one. K8. Let me see. Yeah, yeah. So now it's correct. So now we have the base here going. Oh, okay. So this resistor is definitely incorrect. The size. Because we don't need like a transistor, sorry, a resistor this size for the base. Yeah, so I'm gonna need to change that footprint. Okay, so it's ugly, but at least it worked, so we can proceed. So I'm just gonna replace all of them now. And I'm gonna fix it later because, like, yeah, my responsibility on this live stream is to route the board, not to rewrite the schematic. Yeah, you see that it does not even grab the, because like components like things are in millimeter, other things are in imperial, and I hate this so much. Did it connect or not? Oh Jesus, this is so ugly. I'm just gonna die. One more. Okay, so our high side. The problem is, there's a lot of transistors that are the same. Cat, please send me the correct components. Yeah, like it's like all of those transistors are gonna be wrong. So I'm gonna continue like working on the board layout while you fix and send me an integrated library with the schematic symbol working. Okay, so let's start organizing those resistors. And yeah, this R28 is not grabbing. It's, oh wait, I did not choose annotate. Unknown pins. Yeah, something is broken here. Probably this one. Not even sure anymore. Now there's, hello Yoshi, how are you doing? R32 to 36. What? This is not right. Why have the R32 to R36? I didn't grab those yet. Where are you? Oh, here. 32, so those 31 is not one of them. So, okay, so those are the other half. I'm not enjoy those resistors whatsoever. They are so big. They're just gonna fuck up with all my nice idealized layout. So yeah, let's see what I can do. As long as those transistors, those output transistors, they are inside my square, I am fine with that. I'm pretty good. I'm just trying to, I'm fighting with Altium here a little bit. So now I'm gonna reduce my grid to 0.5 millimeter. No, I want to make those as tight as possible because yeah, this region here for me it's very critical. So I'm gonna make like so. Yeah, so this is the ideal distance to me, and we are gonna position those. So 02. Okay, so actually, let me move those those resistors more or less on this. Yeah, like so. Now let's get this one. Those, yeah, because we have a lot of space between them, we can put the schematic designators in the middle that I always love when I have the space because it's basically empty space and it's so much easier when you know what are the designators. Okay, so this goes here, this goes here, this goes here. Okay, so now we can basically at some point this is gonna be like assembled on a pick and place, so I hope so. Yeah, so this is what I hate about Altium. You know, they are exactly the same components. Here I can make them exactly. I know that I can use the aligning function, but why? Why don't you keep the same behavior? I know, because I selected them together, and when you select just one, it grabs other point. My bad. Okay, something like this. We are missing one resistor. Where is you? 26, 26, 25, 24, 27, 28, maybe? Yeah, it's here. No, it was correct. No. Beautiful. I love to see my resistors aligned. Oh, there's no 3D for those. Too bad. No time for this now. So since they are 5, so we can basically just grab them and make like a rough alignment here. I don't care too much to be perfect, but and there is a way to move the designator one component and have that placement point to a similar component. So it's one more and there's all done together. Ah, cool. I would like to learn that, but yeah, not now. uh, okay, all right. So now let's bring those transistors where they belong. And you, I guess I can place here. It's not gonna be, or yeah, not actually. I would like to gain as much space as possible. So if I bring them like very close with their resistor pairs, yeah, I can keep those designators here. Let's keep this one. Here as a, at least the like the component dimensions they are match slightly with the resistors, so I'm gonna have some degree of alignment between the resistors and the transistors. And of course, afterwards, I'm gonna apply the horizontal and vertical alignment. Oh, Jesus, give me this designator. Oh, Altium. It's better to position your designators before you apply there, because if they are like one over other one, so yeah, then. Okay, so I'm starting to get happier because yeah, we have basically all our power transistors over our maximum like heat sinking performance area. This key 8, yeah, so you want to be here, so let's keep you here. And key 9 like so. Key 10 is asking for this position. Q or Q? I don't know. No, this way. And you, I think you like this position. If you don't, we place you in another position afterwards. For now, it's more like rough positioning, guys. So first, I like to make an assessment of the PCB real estate. because yeah, this is basically is gonna define the remaining strategy for the rest of the border. So for now, it's not, I'm not care too much about alignment. I care more about like, yeah, positioning. So as you can see, I have some extra space now on my like optimal region. Yeah, so now I need to decide which transistors. I have space for at least more 2 transistors. If I like move this a little bit here to the bottom, because yeah, gonna do this already. Yeah, so it's like so. Then we have space here for at least more 2 transistors, and those transistors are gonna be or driver transistors. Let's see. I think Q6 and Q20 are the most important ones to be on this region, because yeah, they basically are our drivers. Okay, Q6 and Q20. Let's grab them and bring them to the party. Q6, it's here. Yeah, we could actually have space. Let's see what more I need. I have some diodes to put there. Key Q20, like so. These resistors go away. I don't need them right now. But one thing that I worries were those R29, R30. Let me already like position those output resistors, because I went to. What is here? So, oh no, it's R29. I would like to know if there is like a way that I can organize, the components here in one region, like based on their designators, like when it's all messed like so. R29, R30. Why I can't find them? Maybe they are at like. Oh, those are those massive ones here. Yeah, those need to withstand the output, the full output. So they are big as resistors. Those resistors are there basically for the amplifier stabilization if you have high capacitance loads. So yeah, so they keep the amplifier happy, because you don't want to make the amplifier not happy. And I actually gonna make some changes like so. I guess gonna be prettier. For now, I'm gonna not gonna keep it then symmetric, but yeah. Okay, so let's go back there for driver transistors. We have a couple of diodes here. So this 6 and this 7 and R23. Let's find this R23 first. I guess is a big one as well. Because what is not big on this amplifier? Tell me. Actually, I could be like less dumb and look like so. No, I need to find. Wazi, do you know what the shortcut to? Oh, I found it here. to find a component on the PCB by the designator. I guess there's a shortcut for it. This 7 and this 6. I hope that there are a few components that are through hole. I didn't have time to convert them, but yeah, the 7, the 6. Okay, cool. You only have 4 viewers. That's so sad. Where's people? Call your friends. Say, Vini is cool. Watch his live stream. I need more hours on YouTube, guys. I can't even do like mobile live because I don't have 1,000 subscribers. So fuck YouTube. Why? If I can do live, why I can't? Ctrl F? Yeah, Ctrl F. Find. Yeah, but no. I'm trying Ctrl F and it's just like doing some weird stuff. Okay, so those, I guess, I don't know if those diodes, I guess they need to be thermally tracked. Okay, so they go to, okay, so the base resistor. So we have 16 to 20. Okay, so let's find 16 to 20. Yeah, those resistors are not fine. We don't need to do the size of resistors for the base. Yeah, there are some underestimation going here. Overestimation. Sorry, R39 to R43. I'm just gonna position them and then I go there and. Okay. So I basically needed to like put like R12 and Control F. Let's see. No, it doesn't work. I should. I thought about put some like music, but yeah, but it's so complicated. I need to find like copyright free music, and hey, chip guy. Okay, serious. Ah, let's try. R. Let's try D1. No, it's D1. Oh, it works. Yes, clear filter. Nice. Thank you. Yeah, there's a search in the top. Yeah, close. Oh, cool. But yeah, I could actually, but I did not think about it. And now I'm too scared to deal with OBS and like fuck up the string configuration. I guess this goes here. Where is my, this goes here. So I'm missing, it is this one. Yeah, you are absolutely right, but I did not remember that. It's a good idea for a future live stream. I'm gonna check on. I never check it on what they have there in terms of music, so I don't even know. But yeah, I guess he has some nice music. Okay, this one is definitely not here. I think this is other thing. Okay, so basically now we have all our base resistors. Those, let me see which package is this. Okay, so they are 10 ohm and 25, 12. Dude, this is too big. Let's go there and fix this. Uh, I think I'm gonna put like 0305. Properties. Why it's open this window? It's usually open on the side. I don't know what happens with Altium sometimes. It just do weird stuff. Okay, so footprint. I think I have. I already looks nicely regular. I don't know what you mean. Okay, so let's find here a library with a SMD capacitors. Okay, yeah, it's not a capacitor, but I'm gonna use a capacitor because it's basically the same footprint. Okay, okay. I'm not sure if I can do this and no, what you just did. Select all of them and change all of them. Once properties. Nah, it's not gonna allow me. How to? Gonna need you to go every single one of them. Ah, yeah, that's true. Especially when you can make your board very symmetric. I think it always looks gorgeous. Like the I like when I have like for example differential circuits that they are basically a mirror. Then you can almost make it a perfect symmetric layout. I just love symmetric PCBs. Okay, almost there. Oh wait, but it's 1 watt. Uh, okay, let's. Oh, 0805 is not gonna handle. No, but we don't need 1 watt. No way. I guess Cat is not there anymore, right? Because he didn't send me. I. Ah, what I did here. No. Shift and mouse click. Yeah, and it's usually what I do. Ah, I see. Yeah, I click Shift. Okay. So my bad. I think I was using Control. Let's see if did it work. No, it does. I can't like mass edit with Shift. Doesn't work to me. No. What I did here, I messed with the designators. Thank you, Kat. I appreciate your effort. For cell notate our schematics. Okay. Oh no. Fuck the designator. I don't care. But I don't want a room definition. Okay, so now we have like a proper base resistor. I guess 0805 is fine, right? I didn't calculate this. This amplifier myself, so yeah. Maximum that is gonna happen is to get hot, but it's all right. I guess I like this positioning. Oh, actually they go in the pin 4, so nope, they need to be this way. Like so. The same thing here, pin 4. Yeah, those are already correct, so I can just say like so. This one I don't think it is correct. Yeah, it's not, but we're gonna keep like so as well. So, yep. Then we have on the high side, we have Q6. And Q6 is here, so it is correct. And we already have a 48 volts here. Now let me grab our C6 and C12. C12, C6. So our high voltage rail capacitors. I guess those are gonna be. Wait, there is something. Okay, because those go to the cascode transistors. Well, the original schematic was based on Winfield Hill design, and like it was integrated freaking lab. Oh, thank you so much. So let's save this. Please show just a moment, guys. Showing Edge. Downloads. Corrected. So let's bring it to our workspace. Oh no, it's not here, it's in drive. Downloads. Here's amp. Let's put here. Okay, so now that we have our library, hopefully fix it. I did the existing to the project. All files. This one. So let's go there and see if we have hope. Congrats to Kat for the effort. Now I need to find between those 100,000 libraries that Kat sent me, which one is add the library. Intlib, where is it? Why is not showing? Oh, Jesus. I just added the lib. Why fucking auto doesn't show me? Install it. Install. Integrated. Unrecognize it. It's because it's a lib package and not an integrated. Hi there. It's new to project. Existing to project. Okay, so looks like it's this one, but there's nothing inside. Cat, you sent me. Let me close. No. I did the existing project. Browse. Interact. Yeah. There's nothing inside. Dude, you sent me an empty library. Okay, let's continue. Wildcat keeps trying to send me the right library. I'm fantastic, and you, Kyle? Okay, so we have now those. Okay, let's place those capacitors that I got distracted about then. Those capacitors are massive as well. I'm gonna keep them close to where we actually need them. That is close to the Casco drivers and whatever. And then we have more two small capacitors here. There are C15 and C7. No, I didn't. I was working on the software, and yeah, I'm always like moving, from the different projects. So yeah, I just touched like PCB project today. Remember me after the live stream. I think I already told you this last week, but C7. Let's find C7 here and using our new searching tool. Yeah. Oh, this is so much better. And we put now C7 here where it belongs. Close. And okay, so the next one that we need to find is C15. C15, and here we have it. Yeah, but really remember me and push me to do it, because it's not that I don't remember, but I keep thinking, oh, I need to do that later. I need to do that later. But because I don't switch tasks and I keep like doing, I end up not doing. So I need actually to stop one thing and go there and do it. Uh, Anyways, you know what? I was planning to clean the project, but since we were talking about this, let me just open GitHub and push. I don't even remember which is the correct project right now. It's the control module. Okay, so yeah, there's a ton of stuff there. Yeah, it's really kind of. I'm gonna put in the commit a mess of files. Yes, I have Discord. I can send you a server settings, invite people, copy. Yeah, a mess of files. Okay, OSMU control module is the repository under spooling the project files there. If you have any issue, you'll let me know opening the files. Okay, so now we have our capacitors here where they belong, I guess. And I guess we have a few other diodes as well. You're welcome, Kyle. Now we have those diodes, D4, D5. So let's find them. D4, D5, D4. Yeah, so D4, D5. Sometimes you just need, to do not work on a software. You just need to stare the entire user interface until you understand each one of the buttons of the inputs, because yeah, you are always missing some things obvious on the in the layout, because yeah, you don't stop to actually study the interface. I do this frequently. Now we have D8 and D10. So D8 and D10. All right. Clear filter. This guy goes here. This guy goes here. Maybe this guy. Oh no, they are. Yeah, they are kind of in parallel, so I can't do what I was planning. But this is already like starting to get satisfying symmetric to me. So yeah, we can like start to get excited about the symmetry. Let's look into the 3D for a second. Oh, look the symmetry coming, guys. It's gonna be gorgeous. Yeah. Oh, okay. Yeah, no, but I'm already happy that I found the search function. Like I just use Altium for a hobby, so like I don't use it professionally on a daily basis. No, usually I consider my PCBs professional enough. But yeah, what I mean is, yeah. So now this R29 is gonna need to be in the middle because he is alone here, and I'm not gonna live with myself if I don't like do like third times the charm. Vini, check this to core. Oh, you have more. Oh yeah, now you sent me an integrated library. Thank you very much. I accept you, Caio. uh, I'm gonna I already did. So yeah, those diodes, they should be together electrically, but I'm not gonna help myself to keep this resistor here because of symmetry. Oh yes. Well, it actually is not bad because I can actually do. Let me see what connects where. Maybe I can do this. And then I do this. And this. Then I can like trace between under the resistor the connection. Let me grab a bottle of water, guys. Just a second. Where's my OBS? Oh, wait. Oh, let me adjust this. The sun is like burning me in dots right now, so let me close the windshield. Yeah, better. Were you able to get a copy of Doom for free? Oh, it's actually not for free, but yeah, I know someone that has a license lets me use it. So for me, it's for free, but someone is paying. Uh, all right. So now we go to the next transistor. So we populate Q20 and 6, and now we have Q7 and Q19. Q7 and Q19. Those. And now is the moment that I start actually to squeeze those components because I want to bring yeah, I also need to apply the fixed library that Cat sent me. Okay, so this resistor goes like so. I love you. And yeah, actually those green, I don't care about those too much. Yeah. It's my like mechanical constraint because I think those are MELF diodes. No, I don't swearing. I love MELF. People usually don't like MELF, but I think they're so easy to get with tweezers and um, R21 and R27 right now. So R27, R27. The next one is R44, R50. They are close, so. All right. I like you a lot, so. Key 7, key 19. Okay, and they are close to the basically other base. I'm not running exactly out of space, but key 7 close to key 6. So key 7 close to key 6. So you're gonna be here. And you are gonna be here. I maybe should change this like so. What do you guys think? Should I keep the same positioning I was going through already, or not? I guess, yeah, I guess we could go this way. Yeah, those transistor. Yeah, we have a lot of transistor that needs to be thermally tracked here, and unfortunately, well, they're not gonna be in the most like heat sinking efficient part of the schematic, but I'm gonna have a thermal plane under all those transistors afterwards, so they're gonna be connected by copper. And the thing here, the most important part is that they need to be thermally tracked, and we don't care too much about like heat dissipation because those are the drivers. Yeah, they got a little bit hot, but they don't get hot as the output transistor. So yeah, I'm gonna definitely keep the output transistors over our square, and those, yeah, those are just gonna stay there. And I guess since I need this rail here, I'm gonna keep those. I'm gonna move those capacitors like so. Well, yes, but it's not just a copper plane because this heat sink, it basically is flat, and this is the reason that I'm going with a super micro heat sink. And then we basically gonna have the thermal pads under the whole board. Um, so and since like the heat sink base is copper, there's a lot of copper providing coupling. So yeah, I'm pretty sure it's gonna be fine. All right, so now we have. Kat, could you check those resistors? I think we can reduce their size as well because they're just providing biasing for those two motherfuckers. I doubt we need like a massive like what is the like we don't need the 1 watt of. It's like 35 R their value. Please check this because basically those transistors, they are working as a diodes. No, they are not working as a diodes, but yeah, it's kind of like diodes. They are, how it's called. This is when you adjust your threshold. Those can be 06, 03. Oh, okay, so perfect. So we're gonna move right now. And please keep an eye on those resistor sizes since you more or less know better about. Yeah, but like on the schematic, like on the parameters, it's saying 1 watt, so if says 1 watt, I need, yeah, you can see here ratings 1 watt because you don't proper manage the components on your fucking libraries. So I don't know the dissipation, so I need to assume it. Yeah, exactly, bias generators. Well, but there is actually a name for when you basically define how much your diode curve, where you want to track. I was reading about this these days. Okay. Okay. Oh, let's grab this one. Now we change. Let's like so. I need to change the transistors. Well, I'm gonna place all the components because yeah, that's pin wrong pin out now. I don't care. Before we start to actually route this board, and as you guys see, this is gonna take a while because I don't even, yeah, we are like 1.5 hours of string and we are just placing components. So okay, thank you. Yeah, so now we have yeah, those capacitors, can go like so. And now that those resistors are way smaller, and now we have space for them to stay here in the middle, like so. Let's grab our next candidates. And our next candidates, they are Q24 and Q1. And those don't need to be, no, okay, so no, there's some, I'm missing something here. Why this Q1 is not asking for, no, that's wrong. Or this transistor needs to be thermally coupled, or this one doesn't. And I guess it needs. It's just Cat that forgot to put the. Okay, Q24 and Q1. Let's find them here. Oh, there's so many transistors yet. Oh. Q1. Q1 should be around, oh, it's here. So Q1 is the high side, so high side stays in the right. And Q24, it is on the low side. So for now, let's keep this. I know. You go here. I'm not gonna have enough space to keep all of them online, but yeah, it's actually, we shouldn't be doing this anyways. Probably there's a big chance that I actually gonna move this to, well, other place. But for now we keep here. Then when we start like looking into the roads, when we have all our nets more or less aligned, we're gonna be able to actually, let's see how many people. Oh, we have 5 viewers. Oh. Guess more like so. Now the next transistors, and I think those are the last one that actually must be thermally coupled, are the Q2 and Q26. Q2, Q26. Now, let me think about it. Now we are going through a region. Yeah, now we're going through a more higher impedance region. So actually, would make sense to keep on this side because here is our input. So yeah, so Q2 is in the top side. Is our high side. High side goes to the right. Q26 is our low side. And now we have those Q23, Q22. I guess those are gonna be more or less here in the middle. And then I have Q4 and Q5. Hey, and we are almost done with our transistors. It's like the critical part. Then we have like what are those two big ones here? We have some small transistors, but those I don't care about them. Q25 and Q3. Were those? Q3. It's here. Mm. Those are basically 15 volts. I guess those I'm gonna change a little bit. I'm gonna start. What was that note on the feedback? That note says feedback node. Do not wrote this line close to high current nodes. Ask me how I know. This is a cat note, so ask him how I know, how he knows. It was funny, I can tell you that. Um, okay, so now that we basically finish up our, I guess here to be perfect today they must like fit like so, but I don't think we're gonna have space for. Oh, no, it would be so perfect if we had, but we don't. So yeah, we're gonna need to do something like those are basically in parallel. So there kind of could go like, I don't want to keep it so close here to the, but we can do this. So then you come like here. I don't want to keep it close to the connector, not right now. I want to have like some routing space on that region. Yeah, so, and we're gonna have some resistors to fill this void here. But yeah, look that, starting to get, let me just adjust those big ass resistors here because they are killing my symmetry need. Yeah, much better. And I put like the origin exactly in the middle of the board, so then I can come back here and see, oh, let me see, and the X here is 2.5 millimeters, the X here is as like, oh, it's not 2.5, but then I can fix, you know. Yeah. So that is the idea, but it is what I'm gonna do after the live stream because it's symmetry craziness. Um, anyways, what we are missing? Oh, I wanted to started to position those like voltage rail things right now. So we have, okay, we have so Q24 and 25. Where is the 24? Ah, okay, you. Okay. So actually, you guy, you don't need to be there. You can be here. Yeah, because this is already like voltage rail clear filter, and you could be like around here, and you two then can go lower. And then now I have space for this one. And now our life is gonna be, yeah. Yeah, so now that we have those, I can start working on D11. Let's find here D11, D11. Okay. So low side diode, and then we have PS2, that is our DC-DC converter. So, and this one automatically goes on this side. And then we have VR1 and VR2. Those are our TL431 references. Then we have L1 and L2, and I guess those don't have correct footprint yet. Yeah, you see, and even they have different footprints for some reason. So yeah, those inductors, I'm gonna change the footprint afterwards, but the size is gonna be basically the same. So I'm not gonna bother about this right now. Then we have, yeah, and in this case it says it needs to be more than 0.6 watts. So R6 on the PCB. So on this case, I agree that this needs to be a big as Then we have here as well C20. Oh no, it's not on this box, on this one. C20. Okay, so U goes on this side as well. So we are gonna do this entire block, and then we replicate on the other side, and then right in the wrong box again. C17 as well. It goes on this side. I am optimistic that we're gonna be no, as long as no one forces me to use KiCad, I use Altium. And I'm using Altium right now for OSMU because this is in a prototype version. When we come up with the final design, then the idea is that we get someone that wants to collaborate in the project and converts like from Altium, like the final schematic and the final PCBs converts from Altium to KiCad, so we can have a fully open source with free software. But for me, it's too slow, KiCad for me, because I don't use it. And so while we are in the prototype phase, we just figure out, let's use the tool that we think is more comfortable, because it's way faster, and like I use, Cat use, you use, so yeah, Auto just work better at this point, and then when we have the final, then someone can just replicate, because the design phase is the most important one. Afterwards, it's just a matter of documentation. Then we don't need like a senior engineer to convert it to KiCad, right? Okay, so we have this weird diode with a weird designator here. Yeah, I know why. This is the reason this diode. It could be like or a resistor or a short, and this is kind of a weird component that I don't fully understand. I'm just following what Kat told me. Okay, R57. R55. R55. Yeah. I think did I forget anything? Oh, I think this C18. C18. To put this block together. Oh, D13. Okay, and this is one of diodes that has the wrong footprint. It's a little bit bigger, but then yeah. For now, we have space. If I run out of space, then I start like optimize. Have all the components for this size. So let's clear this filter, and now let me see what connects were. Okay, so Q24 is our guy that goes here in this in the upper region. So let's start around it. So we have this D11 with D57. See that it goes on that region, so I'm gonna keep here on this top side. It's a diode that does know if I on a resistor, I on a diode, or I on a short. Yeah, I'm gonna show. You're gonna understand a little bit more when I. This is the heat sink that we are gonna be using. And this heatsink is gonna be attached to the board through a thermal pad. And this heatsink basically is this board size. So the board is gonna be fully like in contact with the heatsink, because this heatsink specifically has like a plane, right? A single plane on its bottom, so we can have the entire surface of the PCB in contact with the heatsink. The reason that I am keeping the components in the middle is that the heatsink is optimized, as you can see here in the top picture of this heatsink. We have like a vapor chamber right into the middle of the heatsink, because yeah, the processor is in a rectangle here in the middle. This is where the processor must have a contact. So as you can see, like the vapor chamber is actually bigger than this region based on the picture. It's more or less like 15 millimeters around the PCB that doesn't have the vapor chamber. So we should be good most of this part. So what we're going under each one of the transistors, we are going to have many vias that are going to have the transistor pads with a plane in the bottom side, where we're going to have our heatsink thinking be clear when I start like working on that phase. So for now, we are just like organizing yet our board. So yeah, get your mug of coffee, because this is gonna take a while. For C20, there's an issue here, because where this capacitor is connected, you know, pin 1 is not connected. So there is some issue here. So I'm gonna redo those connections. You need to be very careful with this kind of stuff, because this is, yes. Yeah, so there is a few netlist errors here. Yeah, see, now we have a ground that are not being used. Yeah, and they are not connected. So I'm kind of okay. And I need to check if I actually corrected those pinouts now, because I remember that I changed the oh no, it's all right. It's all right. I got the library read made from the manufacturer for Altium, so those are correct. And we have minus, yeah, we have other 48 volt. So I already know that this is the net list that is presenting me an issue. Yep, it did fix it. Is presenting the same issue. Yeah, I think this line is all fucked. So it's all right. And we also can bring this space here right now. If we need more real estate afterwards, we're gonna have like a big component in the other side. Yeah, definitely this is the reason. Have this side done. Now we need only to replicate on the other side like in a mirrored way. 7.5. Let me see here. Well, YouTube is saying that it's an excellent connection, but you know there is. Okay, so this inductor goes here, and now I know already more or less the components, and I can just start. And we have a D2. D2 is here. Let's find this weirdo. Nothing that I could do right now. I think it's possible to change settings. Yeah, like reduce the bit rate. Like enable advanced encoder settings. Yeah, I could like change the latency to fast, but as long as the video quality, fine to wait a little bit until you have the answers. C2. C17 and C20. Okay, so C20 would issues here. I'm gonna need to check this as well. Okay, and so, and then we have C7. C7 is already there, so or it's that. C3 is already there. So we have R3 and R6. Oh, we have a lot of components on this side as well. Oh, what I did. Oh my gosh. Control F is flip. It's not find. I think you is awful, I see. I don't know what I can do. I reduce it here a little bit the bit rate. Let's see if this solves the issue. Oh, I see that is really bad. Let's hope that it gets better, guys. Worst case, if it gets awful, I can start like let me. Looks good to me. Yeah, I changed it. I changed the bit rate to almost half of what I was using. So C1, C2. Pretty sure C2 doesn't need it to be too big because it's only 16 volts. Editing here. Yeah. We actually have space. It's starting to look terrific. Now it's better. Yeah. Yeah, baby. We're gonna fit all those components under the heatsink. Uh, okay, goes. Okay, so most of this current goes to 21. Yeah, Q3 and okay, so it's this guy. Where's Q21? Oh no, Q25. Okay, so since they are here, so this capacitor can go here, this can go here. They're gonna be very close to their sink. I don't know where this resistor goes, but I'm already starting getting tired. Oh, just there's so much to do. We didn't even start roads. I imagine that this would take like, I don't know, 6 hours. But I was expecting this component positioning to be faster, to be honest. Okay, so let's just organize the house. And let's go back here. So D1. D1. So like so. This. So we have a resistor missing here, I guess. Let's see. It's basic. R3X R1. R1 is there. Yes, R1 is there. What is that resistor that is missing? Here is R55. Let's see where R55. Oh, okay. Okay, so R55, it's R6. R6. Ah, okay. This guy. Shift C. Okay, so you goes here, and then you have the two around here. Okay. All right. Let's start to bring those components closer now because, yeah, it's just harder to keep finding things if they are so spread. I usually like to bring them like around the board because then I know where the net lists are crossing, and I know more or less which region of the board. I'm kind of going in a different ways with you guys today that usually I do because we have all this like thermal constraint in certain components. They must be in certain regions. So it's a little bit different because we have different constraints today. So if I have like only like connectors that constrains me, then yeah, then the design is way easier. Then usually I spread the components around the board and I see what is crossing under the board and I start like first defining like sectors and yeah, and organizing my net lists, and then I just bring it then to the middle. So yeah, but it also depends the board complexity. If it's a really big and complex board, then I separate like in sheets and rooms depending. If it's like multiple sheets, then I first I wrote the rooms, and then I bring the rooms together and I start to organize the communication between them. Right, so now we don't have components far away, so it's very easy to start locating things. So everything that you see right now outside of our board is kind of non-critical thermally. I actually, what is this key 18? I'm just curious. I don't remember this transistor. Probably, okay, so it belongs here. Q3, Q18. Okay, it's part of our feedback path. And D9. Okay, so this Q18, it's probably gonna be like around here, I guess. Because yeah, he's basically joining our opposite sides on our feedback loop. There is this D9 here. Let's find this D9 as well, and also bring it closer to his brother, this transistor. Yeah, and U1 is our input opto amp, so we can actually already like start organizing. So we have C9 and C10 that are capacitors, that are filtering capacitors for our op amp. Then we have R16, R18, R16 and R18 around here. I also can see that R12 belongs to this region. Yeah, R12 is our feedback for the op amp. And R20, yeah, R20 and R19, yeah. R20 and R19. Yeah, and I guess R19 we only use when we don't have a differential input. So probably it's not gonna be populated on OSMU since we are gonna have fully differential paths because of noise. Yeah, so now we can organize those components around here. Yeah, not mixing. Why mixing? In N, in P. I didn't change. Yeah, but I got this net name from you. Yeah, like I didn't change this part of the schematic, so if it's wrong, uh, I'm gonna think this about later. Don't worry, I'm not gonna manufacture this board after this for a few days, so we're gonna need to do a proper review on it. But the routing must go. Okay, so it's ground. So and just okay. By the way, where's my there's no ground here because it's differential. I'm pretty sure you did. Didn't you? Oh yeah, you are right because you had the connector. Oh yeah, you are right. It's because yeah, I saw the negative into the. I saw the negative here in the op amp, and I forgot. Yeah, you are right. It's my fault. I changed it. Import change. Okay, so R12 connects our output with our input. So this one could go here. And then C9 and C10 should be closer to the rails. So you go here. And you go, yeah, this side. And you go here. Net elves. Yes. Very much. R16 and R18 should be closer. Where's my R16? Oh, here. Don't cry, R16. You're gonna be closer with your brother because you are a differential input, so you should be symmetric. Now this, I don't even know why you have a so big resistor here, but anyhow. This is basically not gonna be populated if I'm not crazy. And usually I don't. I'm not, so. Okay, so you can go like so. Then R20, what is R20? Okay. Oh, okay. Are you sure about this input? We don't talk about design rules. Yeah, I think for differential inputs, we don't need R20 and R19, right? Um, okay, so I'm gonna move those like so. And I'm gonna place this like so. And then I'm gonna place this. And this R19 is definitely wrong footprint. Okay, so now our input op amp is ready to be moved to his future home. Let's bring those dudes here in the middle and bring you around here, because yeah, only one op amp, only one op amp must be in the center. This is gonna be the most symmetric amplifier ever created. Yeah. Okay, now I can say that all the important components are placed. Oh, I have this trimmer here, but its trimmer is not really important. It's kind of important, but yeah, this trimmer, it's gonna need it to be like, because yeah, it's through hole, and so it's gonna be more or less like so. So I need it to, yeah, yeah. Why not two trimmers? No. One's supposed to be make it this symmetric with only one trimmer. Yeah, no worries. Okay, how many? Let me see what is this resistor size. Look, 2512 on like an input line. Input line has how many milliamps on this line? Tell me. I guess it's pretty much no milliamps here. So I'm pretty much that this resistor can be like 0805. And those resistors are they 0805 as well? No. 2512. Oh Jesus. Let's move on. And okay, these diodes was curious. D3 and D12. Let's see where they go. D3. Okay, they are Zeners. Okay. So one Zener here on key 3 and another one here on key 25. So key 3. So you stay here for now. Then we are gonna convert you. We're gonna, how was call it? Oh, Dragon Ball, when they change. I forgot. Yeah, you know, when they became from like Saiyajin to Super Saiyajin, they had a name for it. Yeah, so we need to do this with the through hole components. That's what I originally found in a huge package a few years ago. The resistor can be 060. Ah, you dude. Super Saiyajin 2. Yeah. Yes. Okay, so when we fix all those resistors that have wrong size, Pepe clap. Marco says me gusta on Discord. um, yeah, so when we fix those, okay, so what is key 21? Jesus, key 21. Okay, so this is the pair with that lost key 18. So we have one more transistor here. I guess they have similar functionality because they are, oh no, this is slightly different as well. Cat, this transistor can't be, this is NPN. Oh, okay, so one is NPN, PNP. Didn't you find a, like, a pair? Oh, just, never mind. Oh, luckily they're they're very close. It's just like the footprint that is different, but yeah, it's basically the same. It's basically the same package. I'm gonna fix this afterwards. So the silk screen looks identical. Yeah, this is gonna need. Yeah, if they are pairs, why did you use different packages? Okay, so I'm gonna use this key 8. Let me see what. Yeah, so the key 21 looks better. So the key 18, I'm gonna fix this right now. And we needed to change the main transistors. We need to fix them. I can't forget that. Well, I'm not gonna forget that, but hey, now we have it. Ah, perfect. Dude, ignore the mismatching 3D model. You don't know me. Looks like you don't know me. Okay, so this now it is starting to come to life. Okay, so now we just have a bunch of boring resistors that we need to fix. I'm gonna get 0805 to start with. Yeah, so this. What I did. Yeah. So, like, wait, what I'm using here. Yeah, gonna use 0603 as well. I'm not sure if I wanna use 0603s because, yeah, 0805 is so much easier to solder. Like, and up to 0603, it's pretty much fine to solder by hand. But for people that are beginners, is like getting in the hard side. I don't have any problems. So since I don't know who is gonna be assembling this in the future, so it's just better to give them a slightly larger. As long as we have space, I don't mind to give them a slightly larger package so they can be happy and not swearing at me because I use very tiny packages. And like so, Kat, I think those needed to be on what? Oh, dude, you're not seeing, but I save like after like 2 or 3 minutes and saving all the time because I already lost so many times. Like, no. uh, okay, so now we know what are the smaller ones, so we can actually start to. Yeah, not that one. Those are capacitors, but yeah, I'm just bringing them close. Yeah, I already lost a lot of stuff on Altium crashing. No. Like usually when I am switching, when I'm switching between sheets, I am already giving like a Control S. Okay, so most of those tiny components here, come on, they're gonna be like input, as you can see. Now we have these other resistors that I don't have a clue. The C8, I guess it goes, yeah, looks like it goes, what? Where the C8 goes? Oh, this fucker. So this C8 capacitor, it connects both sides of the rails, and it's gonna be a pain in the ass to route this, I guess, because yeah, it needs to connect here and also needs to connect here. So I need to find a place to it, like what? Like kind of like here, that like doesn't make too much sense in terms of yeah, it's the place. This empty place is where it belongs. Yeah. So we're gonna have like long traces, but yeah, but there is this capacitive coupling between both of the sides. So and we had that tiny empty space there. So I don't know if this board was gonna work well, but it's gonna look nice. Okay, as you can see, we have other faulty components here with like a missing, like so R13. So let's find our R13 here. Yeah, you. And as you can see, one of the legs is not connected. Let's see, connect. You fuck. Now it's gonna be connected. What worries, yeah, we have a few misconnections yet, so I'm not gonna like consider this board done while Altium is giving me issues. But like worries me that like because of grid layout on Altium, sometimes it does not actually connect net, and for us would be very dangerous here. So I'm probably after like finishing this, I'm gonna go on the schematic. I'm gonna like move the components, delete every single net, connect them again, and then compare with the PCB to see if there is no missing nets. Because when you have an unconnected pin, okay, Altium is gonna cry and say, "Oh, this is not connected." But if there are like different nets, like and they must be connected between each other, and so then Altium is not gonna complain and it's not gonna identify that there is a connection. So we can't risk that. Yeah. So for this reason, I'm gonna need to review this schematic because I didn't made it. So. But it's all right. At least we're having fun. And fun is the most important part. You can run a design rules check on this. That should ID all this missing. Yeah, not exactly. Because as I was saying, if you let's say I have 4 components and 2 are connected on this net, and you should have like a star around, you know, there in the middle, but it's not exactly connected. So yeah, I guess should be fine, but yeah, I'm gonna need to double check. Okay, so now we have those. I'm not gonna position those small components yet because now I wanna go from I'm gonna check each one of those big resistors that we have because I need to make sure they are actually this size. Uh, Guys, how are you feeling about the live? We are already like how long? Stream health. Yeah, like we are like 3 hours already of stream. Um, I'm thinking that maybe we should finish to populate the components today and do the layout tomorrow. The routing, I mean. Um, and meanwhile, I can fix those transistors that are problematic in the schematic, and also finish like converting these through hole components to SMD, and then maybe tomorrow we could do the routing, or I can just go for it and do, but like it's gonna take more few hours. So, but you guys tell me. For me, it doesn't matter to road today or tomorrow. I'm a little bit tired, but I can just keep going. Oh, yeah. Would you mind pushing back the live stream time a couple of hours if we stream tomorrow? Pushing back, you being. Huh? You mean earlier or later? Um, uh, you are in California, right? So I guess it's late there, night. I have no idea what time is. Uh, yeah, we I mean start a little later. Yes, yes, I could absolutely. I could leave it to later. What time is there now? Oh, 4 a.m. Okay, I get you. Okay, I see that those two resistors. Yeah, no, it's completely fine to me to start later. I put like one of our local time here because I thought, I think it's gonna be okay. But I didn't consider my West Coast West Coast viewers. I appreciate that you are at like this horrible time here. But horrible, yeah. I appreciate your persistence to watch this live stream. Yeah, so let's see, those R13 and R56. What they do? Okay, so R13 is here. We have 15 volts going through Q18. Okay, so this component could be half a watt, at least on if this rating is fine. Kat, are you there? Okay, guys. So as you can see, if we are able to reduce those resistors to like at least half of the size, at least 0.805, we are pretty much able to fit all the components on this board. I guess with some tightening, even like with big resistors like this, we have a lot of real estate here. We can make those components tighter, especially here on those two sides. We can make them tighter. So I guess even with this footprint, we could do it. So what I'm gonna do, I think I'm gonna finish for today. So tomorrow morning I can go with Cat and check in the original design what are the ratings for those resistors, so we can use the proper packages for them, because yeah, then they are also more expensive, bigger packages, more expensive components. I can fix the transistors, pin out mistakes, and I can do a little bit of review on this project. And then in the late afternoon, since Wazi wants to be here with us, then in the late afternoon, I'm gonna see like what is like eight in the morning in the East Coast side. I need to check Berlin time for it. Then we do like all the routing on this project. I was expecting to do everything, but since we have some issues and like just to verify those components and like fix the transistors, it's gonna take me at least an hour. And like I wouldn't like to string more than like 5 hours. I think it's gonna be too much exhaustive to me. And like the way that we're going right now, I think that this is gonna take more at least like 3 hours to finish this. So let's keep this way. So I'm gonna leave you guys with this this design right now. So as you can see, we already like progressed a lot, and I'm pretty happy that we were basically able to fit all the components and follow through with the thermal design that I thought would be like necessary for it. I see like a little bit optimization is possible yet. So yeah, so tomorrow I'm gonna have the schematic fixed, those true hole components changed, and all the resistors properly sized to their respective packages. Uh, so yeah, so then we're gonna position all those missing components, and we're gonna do a fine layout. And what I mean by fine layout is, yeah, we're gonna go through every single component, and we're gonna actually adjust then um, on the respective like place to more or less organize the board, and then we're going to start routing, because yeah, I don't want to move components after we are routing, because then yeah, we just start to yeah, to drag our tracks, and I really don't want to go on that road. Yeah, so this is the way that we keep for today. So I hope you are happy with your design so far. I'm pretty happy. I think the board is gonna look gorgeous, and I'm looking forward to assemble this board and to see it working. So see you tomorrow, guys. And I'm gonna book a live stream for us, so you're gonna be able to know what time we start tomorrow. So have a nice Saturday and a nice weekend overall. See you